The last family of functions we have to talk about today are the exponentials, and they are equations you have not worked with before, so this should be brand new to you. And it's going to look something like y equals ab to the x. So the way that you can tell from an equation that a function is exponential is that your variable x, hopefully we always pick x. If they pick other letters, whatever, that's unfortunate. You know how I feel about that. But your variable is the exponent. So you'll notice that right now I know that's all variables. Let me give you an example. Y equals 2 times 1.5 to the x. So in that equation, my variable x is up here in the exponent. That's the giveaway. So right now we're just going to be asking you guys to identify these functions. What family do they belong to? So if your variable is in the exponent, it's going to be an exponential function. I told you mathematicians are so uncreative. Well, hey, where's that variable? It's in the exponent. What should we call these? Let's call them exponential. The graphs will also be something you haven't seen before, but they're very distinctive. So exponential functions are kind of just a curve. And actually, if you've been following any of our coronavirus or COVID-19, they talked about how it was growing exponentially, and they're talking about flattening the curve. Well, that's a special function as it flattens and curves out, but it did start out as an exponential function. We started out with some people with the virus, and it grew exponentially. We're hoping for that to taper off and work its way back down as quickly as possible. However, just a little extra lesson there, exponential functions are pretty identifiable by their graphs. It's a rapidly growing curve, or it could be rapidly decreasing. This is called exponential growth. This is called exponential decay, which when you take chemistry, you'll learn about like carbon-14 dating, and that's exponential decay. You'll also talk about half-life of substances, which is related to the same thing. That's exponential decay. But their graphs are pretty identifiable. How can you identify an exponential function from a table? Well, I'll tell you right now is it looks weird. If we try to figure out what we're adding or subtracting each time, there's no consistency. You guys know how I love decimals here. This, we added 0.8. Here we added 4. Here we added 20. So it doesn't meet any of the criteria we were looking at before. So in the grand scheme of things, this isn't the way to do this, but for right now, if it isn't linear by having a constant rate of change, if it isn't quadratic where the signs change but the increments are the same, and if it's not absolute value where the value is constant but the signs switch, it's going to be exponential. So for you right now, if it isn't any of the others, if we're adding or subtracting weird amounts, that's how you know it's exponential. When you take algebra 2, you're going to find out that there's a constant ratio. We're multiplying by something every time to get here. So even though we can't reach this by adding, we can see that we're going to be actually getting the same value by multiplying. So how do I go from 0.2 to 1? Well, I can multiply that by 5. How do I go from 1 to 5? Well, 1 times 5 is 5. How could I go from 5 to 25? Well, I again multiply by 5. So there's a constant multiple for exponential functions. For you right now, you just want to look at the fact that if you're adding values, you're not going to be able to make it. There's nothing that's going to match up. You're not going to meet any of the other values. You might be able to see what you're multiplying by. And if you can, that's fabulous. And that's what you will be doing actually, in fact, in Algebra 2 when you do these. I know I threw a lot of information at you today. I know these videos are hard to watch by yourself. I try to talk in these the same way that I would if I talked to you in the classroom. Please, please, please reach out to me if you have questions. Email, ask me questions, come to the Google Meet. If you can't come when I've got it set up and you need a different time, email me and tell me. We'll do what we can to try to get everybody as much information as possible. Keep working at it, babies.